Okay. Now we're recording on Teams. So, how's everyone doing today? So, today we'll be talking about the Internet of Things search engine known as Showdown. Showdown, not Showdown. There's a good chance some of you have already heard about this search engine. It's made plenty of headlines throughout its life, and it still makes some headlines every now and then, even today. So it started in 2009, and since then it's sparked a fair amount of attention, most of it being negative. But Showdown is just a device-focused search engine that discovers Internet of Things devices. So just things that are open to the internet. So, these also include your regular web server, just like Google, because Google indexes the content and of web servers, and Showdown indexes the content and the services of not just like the specific website, but just like the network in its entirety. If it's got an IP address, if it's got an IPv4 address, it's going to be on Showdown. So these things can also include things like school HVAC settings, printers, traffic lights, control systems, in-home security cameras, even Caterpillar trucks, even crematorium systems have been found using the search engine. I don't know why there are crematorium systems open to the internet, but there are. But yeah, so if the device is open to the internet, you can find it on Showdown. So with that, it kind of makes sense that there would be concern about so many devices and systems being accessible over the public-facing internet. And when researchers demonstrate how things like oil platforms and medical devices could be targets of malicious attack discoverable on this device, these concerns understandably heighten. But this isn't Showdown's fault. The platform just highlights an existing problem with the infrastructure of the Internet of Things. In fact, the sensational headlines that emerged actually were really helpful to the security of the Internet of Things, as it brought a lot of awareness to an issue that was building, that was pretty underground prior to the platform's release and kind of mainstream discovery. As security researchers use Showdown, they unearth a lot of the gaps in our security infrastructure, and that's unearthing those gaps is fundamental to then implementing proper security and to patch it and to improve our networks and the devices that run on our public networks. And Showdown runs its scans 24/7. It compiles and indexes service banners I skipped ahead. One more slide. Okay. It compiles and indexes service banners to find out as much as it can about the devices, or about the network and the devices that are running on those networks. So this ensures that all of the data on Showdown that's available, that's indexable, is up to date. You're not going to find a scan that was performed like 2.5 years ago, or even 2 months ago. While most regular, average internet users won't need Showdown, and they pretty much have no good reason to use it as well, cybersecurity experts, academic researchers, and government agencies are among the most active users of this engine. But pretty much any industry that can make use out of data, which is a lot of industries these days, use Showdown. They've got API enterprise keys and stuff for large corporations. We'll talk more about those kinds of use cases later. So when it comes down to it, this is all that the algorithm is for Shodan scanning. First, it generates a random IPv4 address. There's 4.3 billion total IPv4 addresses, but after it generates a random one, and if it's alive, which currently most of them will be because like we actually ran out of IP4 addresses not too long ago. Oops, here, let me put myself on Do Not Disturb. After it generates an IP address that is open, it collects a real-time list of those connected devices. And then it queries a supported port. And so it scans more than 250 ports. It doesn't scan every single port because that would take a lot of extra time. And since it runs all these scans in parallel, just if each individual port scan takes, maybe like an extra half second or something, that will add up since there's thousands of ports. So it scans the ports that common software runs on, and also the port above and below that service port, because a lot of admins will just, oh, well, I'll just be clever, and instead of hosting my FTP server on 21, I'll do it on 20. It's not that smart. And so Shodan checks for that as well. So if you did host a service on some kind of like random port, you could kind of avoid that service being scanned, but that's pretty rare. But then after it queries all of that, it checks the IPv4 address on that port specifically. So if there's a lot of devices will have their own IPs, and then it grabs that service banner, it compiles the information about what could be there, and then it just does the same thing again. And it generates a new IP address. And so that's just how it gets this huge list of all of the connected devices just by pretty much brute forcing IPv4 addresses. But there's more. Actually, let me talk some more about this. So it's not too advanced. It just scans random IP4 addresses and ports. Anyone can make their own implementation of a Shodan-like search engine, and because of the pretty simple scanning method, there are actually quite a few alternatives. But it takes some computing power. There's 4.3 billion total IPv4 addresses that you need to scan, not just once total, but you need to continuously scan these, so that way your database is kept up to date. And so to store and index all that information, it takes a lot of horsepower. It takes a lot of data that you need. You need a lot of space. And so you need a certain amount of computing capabilities to do this. So your average Joe Schmo with their laptop can't particularly do this. But there's more to Shodan than just IPv4 scanning. Shodan has pretty advanced methods to find information about the hosts that it scans, and it compiles this information into banners. So when Shodan scans, it builds a banner using various automated tools and techniques. So now, how Shodan works under the hood isn't public, unfortunately. So most of the specific methods they use to determine these specific services and versions is unknown. Of course, they probably use Unmap scripts in there somewhere and some other standard tools, but they also go a step further, but those steps aren't particularly known. But as an example, one that is known, in the case of FTP, one of the ways Shodan tries to identify the specific service and version is Shodan will actually send a help request after it connects to an FTP server to get a list of the available commands that FTP server supports. And using the order and availability of the output of those commands, that creates a unique fingerprint that is then used to help identify the specific FTP software and version. Things like Nmap, and Nmap scan doesn't do that. So, Shodan is doing a little bit more than just Nmap scans on random IPv4 addresses. As I was saying earlier, Shodan is primarily used for legitimate purposes. Although it's got some spooky headlines, it's not just like the cybercrime hotline, right? As some examples, hedge fund managers will actually use it to see what software product is more successful. Like is Kubernetes deployed on more systems than Apache Mesos? Is the state or is the rate of new Apache servers outpacing the rate of new Nginx servers on the internet? These kinds of questions can easily be answered just with the data Shodan provides. It does a really good job at compiling and storing all this information, making it easily searchable. Another example, insurers will use Shodan. Like before providing a policy to a company, they'll look at the network of that company using Shodan, and if they've got a lot of vulnerable services running, or some services that are open to the internet that really should just be internal, they'll use that information to build that policy. And if that network's got a whole bunch of vulnerabilities, that policy is probably going to be a little bit more expensive, right? Shodan is just very good at mapping the computer landscape. And so, for these reasons, it's used by a lot of industries for its real-time insight. And of course, as a penetration tester, Shodan provides a great overview of the target's network, and the information that it provides is a fantastic foundation to build the rest of your attack plan on. If you're an admin, it's also just a good information for if you're managing an enterprise network to know what's available and what's not, like what attackers could know about your network. But we are not hedge fund managers or insurance policy makers. Just share my browser now. So how can we use Shodan? Ooh, need to change the screen on Teams as well. Okay. So how can we specifically use Shodan? We aren't making policies out to enterprises here, and none of us are admins for an enterprise network. Well, if you savvy yourself as an explorer of the internet, Shodan is very handy, and it's truly it's a fun little tool. And before we go into further detail, I probably should have had a separate slide about this, but if you discover any kind of anything on Shodan, if it asks for a password, even if it's like default passwords, don't mess with it. If it's completely open, that's fine. There's no gray area there. It's open to the internet and you can access it. But if it's like a webcam, and even if like the password is admin, don't do it. That's against the rules. But if you savvy yourself as an explorer of the internet, Shodan is great for making these discoveries. So we can make these discoveries with queries. So just like how you'd query Google and how it has like an advanced search and everything, Shodan is very similar. So as an example, when you search something on Shodan, it searches the banners that compiles. And so this is the banner that I was talking about in the slides. This has all of the information about the network, the ports, and it compiles everything it finds into this banner, which is then indexable. So if we Control S it, then we see, oh, okay, so this is the something that's in this banner, and so that's why we got it on the output. Shodan supports a lot of filters as well, and you can actually find a list of them on the cybersecurity website here. We've got queries and filters here, so we're going to look at the filters. So you can search filters, ASN numbers, certain dates, location, countries, cities, ports. And we're going to use the port example here. So like with file transfer protocol, if you open up a terminal and you log into an FTP server, it gives you the output code of 230 for like success, similar to how HTTP has the 200 success code. So if we just search 230 on port 21, we get the output of various FTP servers that have anonymous FTP access. So you can see it here in the banner. It's stored that information because Shodan checks for that. So anonymous user logged in, anonymous user logged in, etc., etc. From personal experience, almost all of these are just empty and there's nothing interesting on any of them. I've looked. But that's just an example. There's also cheat sheets that have good queries. Again, you can find this on the link to this is on the website. So like let's use this query that searches for unprotected VNC. So we can just copy that in, paste it, and we'll get the output of a whole bunch of things that should have protected VNC. And it's just kind of like, what the heck is this? This is a weird looking operating system. Right? You can look at all of these because they're wide open. And so even on the Shodan site itself, it has some queries that that we can use to search for. Like we'll search for this one. Hacked websites. If we look on what this says on oh, that one's boring. Oh wow, fascinating. Here we have a website that's been hacked. So those are just a couple examples. There's also like a quote of the day system. I think what port it runs on. Yeah, some of them will just come out. There's a service that runs on it's just a quote of the day service that will give you a bunch of neat quotes. But there's just a lot of kind of like neat stuff that you can find. It's a fun way. It's neat at the low level of application, but to have a more focused application on using Shodan, we're gonna do the Try Hack Me Room as simply aptly titled Shodan. So this one is pretty self-explanatory. There's little reason for me to go through it as a presenter. It kind of just talks about, gives you the information that you'll need to do this challenge. So instead, I'm going to try to introduce a new concept for the club. We're going to treat this as a little challenge. So whoever finishes this challenge first will get an exclusive Discord role. And yeah, that's it. It's an exclusive Discord role. So if you finish first, just post the snip of the 100% into the Discord, or link your profile because it shows your completed rooms in there, and get competing. And if y'all, yeah, for this one, you don't need it. All these questions can just be answered in your regular browser. You don't need a VM, you don't need open VPN access, just need the website itself, just Chrome, Internet Explorer, Netscape Navigator. Any of those will work. Okay, maybe not Netscape Navigator. Yeah. Oh, and next month gonna be starting is gonna be all about web applications. So that's our announcement that I forgot to mention at the beginning. Also on the the club website is a couple of reading materials, one of which includes just like a full, complete guide to the Shodan search engine. So if this stuff kind of interests you and you find yourself just like looking up random queries on the site, like give this a read over and you can craft your own queries. Oh, and yeah, that concludes the presentation part of today's meeting. Now it's just the competition part. Exclusive Discord role challenge.